Okay, so today I'm going to talk about situational awareness and complex information technology systems. I will be focusing on complex information technology systems. However, non-complex systems also are important in terms of situational awareness, because at the end, even if it is a very simple device or system, if the situational awareness is not satisfied, you will be using the device incorrectly. So what do we mean by complex dynamic systems? Complex dynamic systems has two important keywords. One is the complex, other one is the dynamic. Complex means there are more than one variable that are related to other variables, and the task includes some kind of control work, like operation of certain device, operation of train station, operation of metro, etc., or airplane, and there will be operators, and we will go into examples. So dynamic means time changing. So we will be discussing about situation awareness and automation, and we will discuss some examples. We have some, as I said, we have some two keywords, dynamic and complex. Complex means more than one variable. Dynamic is time changing. It's time changing. Why is that important? Because when an operator is dealing with time changing variables, such as driving a car, such as flying a plane, you need to interact with multiple variables in time, in a proper time, so that actions are taken as soon as possible before it becomes too late. So interaction with dynamic systems is not like interaction with Microsoft Word, because when you are dealing with Microsoft Word waits you, or an animating system, a desktop publishing system, a CAD/CAM system, many applications, a messaging system, an email system, they wait for you. But in dynamic systems, they don't wait for you. Events happen. So usually they are related to real life objects, such as trains, planes, cars, buildings management. Because, for example, there is a water problem in the building, and the water problem becomes worse if it rains. So in order to compensate for the rain, you need to take some measures, and you cannot wait. You have to be acting on time. So those are dynamic systems, time-changing systems, time-dependent systems that are connected to time variable. And we have multiple variables, relatively complex, including more than one variable, which will cause problems in understanding. And of course, why do we do it? Because we are controlling our environment. Driving is an important dynamic complex behavior. Driving of a car, you are interacting with a lot of external signs and variables, the condition of the car, speed, position of the gas and the brakes, etc. So there are multiple variables. So actually learning to drive a car is a complex dynamic control behavior. And it is affected by many external things. Interestingly, autonomous cars are trying to tackle the problem, and as you can imagine, the problem is not an easy problem. It is complex, dynamic control problem. So one example, a traditional example is the train traffic control. I'm not sure if it is too difficult or not, but it's kind of complex if you look at the control rooms. So there are multiple trains going forward and backward on the tracks, and in order to prevent the problems, there is a system and the people interacting, monitoring the system. So from time to time, they need to interact with the system and give commands to control the trains. So if the situation awareness, if they are not aware of what is happening, then there will be problems. One typical example is this guy falling into a sleep. So if this guy sleeps, then it is obviously not aware of what is happening. But it's not as simple. It's not only sleeping. Similar things are true for the driving behavior. In order to lose control or lose the awareness of your surroundings, you don't have to sleep. Obviously, sleeping is important part of it, but you don't have to sleep. You begin losing ability to understand slowly, and after a point, you start watching what is happening, but not you are in the control. You will be watching as a spectator. So that will be losing the control of the situation. Experienced pilots and experienced drivers are less likely to lose control in emergency situations, but novice apprentice drivers and pilots and control operators, in normal conditions, they operate fine, but in abnormal conditions and emergencies, some of them fail to control the system correctly, and that's partly due to training and partly due to the interface. Yes, same control room. So train drivers are also interesting example because it's unlike the car. Generally, train goes by itself. So train driver can talk with the phone, so briefly look somewhere else. So it's kind of, I haven't done it, but it's kind of boring to me. So if the task is kind of boring and repetitive, then you may end up losing the awareness about what is happening, whether the engine is overheating, whether there is a problem, where is an oncoming train from the forward. So how do we prevent this? The solution is you need to provide user interface cues in order to support situational awareness. If the user interface is not sufficient, then situational awareness goes bad. The famous 3 Mile accident in the United States, nuclear disaster, was mainly due to situational awareness problem of the workers in the control room. So control room operators are not aware of what's happening, then the disaster happened. I think also the problems in Chernobyl is also due to situational awareness issues. Due to situational awareness issues, they couldn't realize that there is a problem in a proper time. There were signals, but they were not aware of that signal is very important. And this is also ship control. Ship control is interesting. It's a dynamic system. It's a complex system. but the behavior of the ship is kind of delayed. The commands that you give puts effect after few seconds later, or few minutes, maybe multiple tens of seconds later in big ships, maybe minutes. Therefore, you need to simulate. I will talk about it later in detail. You need to simulate what will happen in your mind. You need to simulate it, and based on your result, you give the command. Some of you are using ferries and ships in Istanbul, probably, and you may have seen that the captains are approaching to the dock port very swiftly. So they come very fast, but suddenly they slow down and turn. So the commands for that maneuver is very difficult and requires simulation in the mind in advance. And they give commands before it happens, few seconds before, multiple seconds before, but the ships behave in accordance with their expectations. So partly training and partly user interface is important in providing these awareness issues. There are other examples like agricultural machines, chemical systems, and tree cutting. Tree cutting is interesting. When you are cutting the tree with the saw, the famous problem is which way it's going to fall. So as you cut, you need to simulate what will happen so that it will be landed down to the correct position and correct angle. So you give the commands and you change your behavior according to that. So that is what it means, situational awareness. So if you are not aware of the situation, you will fail. This is another open mine in stone crushers. And medical facilities, there are significant mistakes in medical history. Some of them are attributed to technical issues. Some of them are attributed to user interface. Some of them are attributed to the situational awareness of the operator. But due to bad user interface, situational awareness is not satisfied. Then if it is not satisfied, the user will give incorrect command. The patient has high blood pressure and sugar and some other issues. If the doctor is not aware of all the factors correctly and meaningfully about the patient, she or he will give incorrect they are not aware of the situation of the patient. So how do we improve it? Through the user interfaces. This requires a combination of human system, technical system, and organizational system. So it's a combination of, in order to be aware of what is happening in the complex dynamic system, it's a human issue, technical issues and organizational issues come together. As I said, in the medicine, human body is also a complex dynamic system. when you are giving medications to the patient, you should treat a human body as a complex dynamic systems. There are variables, there are internal variables, external variables, linked variables, etc. So there are outputs, inputs. So that complex dynamic system sometimes fail, sometimes get some disease. So in order to cure those diseases, you need to understand, you need to be aware of the situation of that complex dynamic system, so that when you give a medicine, you should be able to simulate what will happen in your mind at the beginning, in your mind, so that you will be sure that your decision is correct. So the fundamental properties are systems are complex and dynamic, as we discussed, and the control is indirect through the interface and through the control system. So the results are not visible immediately. Results are visible later and indirectly. Demand is high. There is a high demand of speed, accuracy, quality, safety. So it's not an easy, obvious task. And interfaces usually provide inadequate support, and operators are not always good. I am excluding the doctors and other professional jobs, but in the operator level, in the factories and mines, workers are working in shifts. Some of them work in the night, so they are not always best people, and their performance is not always the best due to external factors. They are tired, they don't have sleep in the night, etc. So how do we improve them? Generally, when we look at the the failures and accidents in the early days of industrial revolution, machine-related accidents were very high proportion of the total accidents. As time passes, machine causes are decreased significantly, and human cause of the accidents increased. So since the human cause of the accidents increased, that's basically the user interface, nothing else. If the user interface and system design, if the system design, and not only the user interface, but also the system design together is incorrect, then accidents will happen. So situational awareness, SA, means to be always in control in the loop, because in the dynamic system there is a loop, time loop, and in that loop, if you are in the loop, then you are in charge, you can control the variables. But if you are out, then you have lost the situational awareness. The famous book about situational awareness is Ansley's book about situational awareness, analysis, and measurements. I am doing a research on this with one of my students from TÜBİTAK, and it's kind of interesting book, and they propose a model that tries to measure and improve factors that affect situational awareness. So, as I said here, today around 88%, 90% of the human error is due to problems with situational awareness. So many times we say situational awareness, but but the human is not the one to blame. It's a human error, but we can't blame them. So let me give a small break about discussing something else about that situation awareness. So do you remember this accident? Oh, sorry. So it was several years ago, and this. Evet, diyor ki Şarja havaalanı kalkışlarından sonra uçak doğru bir ivmeyle yükseliyor. 36.000 feet'e geldiğinde pilotlar hava trafik kontrolünden 38.000 feet'e çıkmak için izin istiyorlar. Daha yüksekten daha az yakıt harcayarak daha az trafikten etkilenerek uçmak istiyorlar. İran hava sahası meteorolojik olarak çalkantılı. Pilotlar türbülanstan en az etkileneceklerini düşünerek yükselmek istemiş olabilirler. Tamam. 36.000 feet'ten yeterli düz uçuş yapmış. Burnunu ağır bir ivmeyle kaldırarak tırmanışa geçtiği sayılır. Bu arada uçak birden anormal duruma giriyor. Uçak pilottan da 60'ta işaretini tutmak için ciddi güç gerekiyor. Stall oluyor. Daha sonra dakikada 13.000 feet, dakikada 4.000 metre kayıpla düşüyor. Tırmanma hatası, yangın parça kopması vesaire. Burada tam olarak söylememişti, bakayım. Da bilmemişler. Şimdiki buradaki mesele kara kutudan sonra ben bunu tekrar inceledim. Evet, bu dursun. Yukarı çıkmak istiyorlar. Tamam mı? Göstergelere bakıyorlar. Çıkamadıklarını düşünüyorlar. Daha çok yukarıya çıkmaya çalışıyorlar. Ve bu sefer de uçak böyle dikiliyor, geri düşüyor. Burada hız göstergesinin donması ve uçağın hız ve yükseklik göstergelerine pilotun inanmaması. İki ayrı gösterge var. Bir tanesi donuyor, bir tanesi donmuyor. Hangisine inanacağını şaşırması sebebiyle. Burada ciddi bir situation awareness meselesi var. Uçak çıkıyor mu, iniyor mu konusunda pilotun şaşırması söz konusu. Bu aslında evet pilot hatası ama aslında bir user interface hatası. Çünkü doğru bir şekilde söylemiş olsan pilot bunun için yanlış yapsın ki? Yapmaması lazım. Demek ki biz ona ifade edemiyoruz. O bilgiyi kendisine doğru şartlarda veremiyoruz. Bunun çeşitli sebepleri olabilir. Başka yükler olabilir. Algısal yükler olabilir. Yorgunluk olabilir ama interface'in yeteri kadar bilgiyi veremediği buradan anlaşılıyor. So as we say, 88% of the human error is due to problems with situation awareness. So how do we define it? Once you have situation awareness, then it will provide correct decision making. Then it will increase the performance, or it will satisfy the conditions for success. It's a key to good decision making and good performance. In airplane scenarios, you can even die for that reason. It's critical in wide variety of domains as follows. In aviation, air traffic control, in the army, maintenance, military command and control, intelligence, space, power systems, oil, gas transport, everywhere there will be complex systems, and if you have problems with situation awareness interface, then you will have problems. The technology of airplanes is relatively old enough so that superior technologies are embedded in many parts. One of them is heads-up display. The heads-up display here, you see, heads-up display shows important situational information in front of the pilot all the time, so that pilot is aware of what is happening all the time. Obviously, this display is not available to commercial airplane pilots. There are dashboard ones, but this is kind of important. So all the critical information is put. So therefore, our principle must be putting the right information to the right person at the right time. That is, where is my cursor? So right information to the right person in the right time, in an understandable and usable form. So it is the most important part. And our reference is heads-up display in airplane fighting computer. So, however, in the military computing systems, variety of technological devices are given to soldiers simultaneously. Then it will create situational awareness problems because many devices create information that is much more than a person can take. Therefore, there could be filtering and processing, pre-processing systems as a user interface for augmenting all these information and filtering and helping the user. In this case, it is the soldier. If we go back to definition of situational awareness, it is the perception of environmental elements with respect to time and space, and comprehension of their meaning and the projection of their status after some variables has changed, such as time, so it's dynamic. It involves being aware of what is happening around you to understand how information, events, and your own actions will impact your goals and objectives, but now and in near future, now and near future. So it's kind of prediction of what's going to happen. Ansley made a model explaining situational awareness. Some books talk about situational awareness. Some book says, Ansley also, situation awareness. Situation awareness and situational awareness are variances in English. But when you type Google about situational awareness, then a lot of personal security personal security documents and pages come up, because it is also related to, the term is also related to what is happening around you as a person in the organization, as a person in the street, as a person in the family. So that is also named as situational awareness. So situation awareness in command and control is more related to our focus. So here we have 3 levels of situation awareness by Ensley. One is the perception, then we have the comprehension, then we have the projection. So if we have all the levels fit, then we will make decisions, and the results of these decisions are perceived as result of the actions, and results are perceived, recognized, and processed again. So it's kind of a loop. Obviously, there are factors affecting that, such as system capacity, interface design. Here, interface design, automation, and stress, workload, and complexity, etc. Also, you have the goals and objectives. If the goal is not that important, your motivation goes down. But if it is a life-threatening situation, it changes the behavior of the situation awareness. Whether you are paid or whether you are not paid, whether it is very critical to you or not critical to you. So how important is to you, etc. And based on the experience and training, decision making and observation and projection abilities also change. If you have any questions, let me know. So these 3 levels of situation awareness is the perception, comprehension, and projection. You first observe, then understand, then project the value, so that what will happen if I continue like this. Perception means observation. Comprehension means modeling. So model is okay in your mind. And projection is the dynamic information and running the model for extrapolation and prediction for the future. In the level one situation awareness is the perceiving. Many problems with the user interface are due to perceiving. They don't see it. If the variable is not seen, it's impossible to understand. So that is level 1. Second is understanding. So interpretation and evaluation. It requires integrating the information to understand how it will impact upon the individual's goals and objectives, such as engine heat. Engine oil blinks. You see it, okay, engine oil blinks, but do you understand how important? That's one thing. Some people say, oh, engine oil is important. So that fix it. They don't comprehend the fact that it has to be addressed immediately. So they don't know the importance. In the third level, in the car engine issue, they may not realize the consequences. So if they behave like that, or if they change some variable, do they predict future? They may say, this car can go like this back to home. Some other says it can't go back to home. I have to pull over. So it requires simulation in your mind about the system. And then whether you go back to home, it requires extrapolation of the variables. It's critically important in complex systems control, like train tracks control, ship control, because results are also, it's true for web server control. You open up a web service and immediately everything after a few seconds. As you open up web services and connecting software to each other, you need to be able to simulate what will happen near future so that your actions are planned. So this is what the future version of the same thing. First, the environment is perceived, the interface, through the interface it is perceived, and you understand it, then you make the projection and make your decision and change and project again. Perceive it. Based on your mental model, these all are affected. Okay. So what kind of situational awareness that we have in general? 80% of the cases, the problem, the information is not seen from the user interface or not provided. Second, they don't understand. They see it, but they don't understand it. They can't project what will happen in future. It's very small percentage. It's like 5% of the cases. They cannot make projections. So we have to first focus on they don't get information that is needed part. However, if we put information in front of the user, the performance of the people reduces. So when you put all the information to the user and say, take what you want, it's not correct. As you increase the amount of information, accuracy drops. It doesn't increase, it drops. So actual accuracy drops. Therefore, we have to be somewhere here to limit, by limiting the information and by filtering the information that is only necessary to understand the situation. Otherwise, they will not be able to understand it. They made one study given in Ensley. They made questions about the problems. And many times, failure to observe, failure to monitor and observe data. Some of them are misperception, forgetting, hard to detect information, and information is not available, not given. Blue ones are normal controllers, and the brown ones are pilots. In the pilot case, biggest cause is the task distraction, doing something else. Others are not that important. One important thing is also the workload. Okay. Also, in the pilots, reliance to automation is also a cause of problems. If everything is automatic and you leave it to automatic and automatic fails, then you also fail. So general problems can be summarized as attentional tunneling, memory trap, workload fatigue, misplaced salience, complexity creep, incorrect mental model, and out-of-the-loop syndrome. So I will explain what they mean. Attentional tunneling means focusing on one area or issue and forgetting the other part. Memory trap means over-dependence on operator memory for effective response for alarms under different operating conditions. So operator has to remember about cases. You are relying on operator's memory, the person's memory. Abi unutma bunu falan tarzı. Then it causes problem. 3, anxiety, fatigue, and other stress factors impact performance. That is critical. Overload of data, too much data, excessive amounts of alarm information, too many lights in front of you, and they are all light. So which one is important? They cannot distinguish, meaning data overload. Misplaced salience is incorrect alarm priority and or human-machine interface representation of alarm importance and other status information. So one thing is blinking, one thing is blinking, other thing is lit. What do you think, which one is more important? Blinking is more important. However, it's not. Continuously lit could be more important. Therefore, ordering the importance of the elements when you have multiple alarms creates problems. And in the history, there are big disasters due to this. So the system designers should order the importance of the alarms carefully in the interface. The next one is the complexity creep. Complex response or complex human-machine interaction features that increase response complexity. So if the user interface is complex and you have to do complex things in the user interface, then eventually it will fail. Sometimes the understanding of the underlying model is incorrect. If the model is incorrect, then interpretation becomes totally incorrect. If you don't understand how the car operates, how the brakes operate, how the ship operates, then it will be very difficult to use the dynamic system. Last one is the out-of-the-loop syndrome. It is like becoming a watcher instead of controller when the automation fails or when the automation acts differently than you expect. You are out of the loop and automation does something by itself and you just watch. It is typical for some drivers to watch the accidents when they are in trouble. They can't do anything. They cannot intervene or control their cars once the accident starts. That is partly due to interface and partly due to the training. For example, if the car skids a little bit and then some people just watch and do nothing because you are out of the loop. The data overload is still a problem for the human. Although the technology is improved, data is still too much to handle, too many data to handle. Our brains are not capable of handling that much of data. So interfaces and computer systems should pre-filter the information that is necessary to be submitted, to be shown to the user. So what we need is not much. What the produced data is too much. So if we develop an interface like this, usually human failure occurs, but we have to find the correct ones. These must be correct in order to operate the system. Incorrect variables are usually not beneficial. So one of the reasons that system development, especially in complex system development, there are multiple vendors, multiple devices. Each device is trying to communicate with the person individually. So there is no combining master computer that interacts as an intermediary between the user and other systems. Other systems are integrated, separate. They are integrated, but they are separate. So one user-centered design philosophy is there will be systems and data sources, and they should be incorporated into one single system, and then it should be given to the user. So one famous example about this is the difference between Airbus and Boeing. Boeing planes are like this, so there will be different systems. Each of them will be directly accessible by the pilot. Everything is visible, but it is complicated. In the Airbus, only necessary things are shown to the pilot. If the situation is not requiring attention, it's not shown in the interface. So the result is the interface of the Airbus is less complicated. But one of my friends is switching from Boeing to Airbus, and they are getting training in Sabiha Gökçen. And he said Boeing is much more clear and predictable, but Airbus is not predictable that much. So he said situation awareness in the Boeing was better. However, he has been flying with Boeing planes for 25 years, and it's only 3 months that he started training with the Airbus. Maybe it's due to that factor. So in terms of safety, again, 80% of the things are caused by human error. So the human error is situational awareness problem. It's the primary factor. So train tracks. And operator, there are two different approaches to control. Control by exception, control by awareness. In the operator case, in the exception case, operator cannot work without situational awareness. It has to be there. And operator will always try to obtain the situational awareness. If not properly supported, you need to simulate, you need to predict too much. You will say, maybe the system is doing this way, maybe the system is doing that way. So you need to be in stress too much if the interface is not giving you enough information. So if If you are familiar with the task before, then you will be successful a little bit more. And if you are trained, if you have done the task before, your performance is a little bit better. However, it's not zero. This is an interesting example. So instead of this static information, 85 degrees, is it hot? Is it cold? We don't know. We have to be experienced about what it is. Is it in Celsius, Fahrenheit, or is it for the house? Is it for the engine? Is it for the hot water? What? But when you show this dynamic information, and in the left one is the temperature, you know the scale. Then it can be also colored, green or blue or whatever. So you are aware of the range. And if you graph this, then you also realize that how the system is performing in the past, how the system is going, where the system is going, it is increasing, etc. So you can make more estimations and more understanding. Also, upper limit, and lower limit is shown there. That increases understanding rather than giving 85 as a variable. This is much more useful in obtaining situational awareness. And this is a typical SCADA factory automation control room interface. In this factory control room interface, we see some graphs like this. So these graphs show historical data for understanding the variables, the behavior of the variables. Also, there are some color changes. So these color changes are critical values. It's behind me. Critical values so that users can understand these for more important factors for situational awareness. So it's actually a good one. This is called as Murray diagrams in train control. In train control, these are the vertical axis is the time, horizontal axis is the location, and these are the stations. Each vertical bar is the station. So this is one train going from Ankara to Istanbul, stops in Polatlı, stops in Eskişehir, stops in Gebze, Bolu, etc. So, and this is the second train after that. So if the separation between two trains are getting closer, it becomes narrower. If they are getting away, that it means there is a delay. Also, for example, here we understand that there is a delay and the train waited for a while in that station. This is typical Murray diagram. So in order to make a situational awareness oriented design, first we need to understand requirements, then we'll make our design based on the situational awareness principles. Then we make measurements. There are design principles in the book, Anzi's book, Designing for Situation Awareness. So these principles are very interesting. And that requires understanding of the human-computer interaction, physical interface optimization, human factors design principles together. The combination of information, some of them are physical, some of them are cognitive, and the situational awareness oriented design is at the top. It requires a lot of work in cognitive part. Situational awareness design, situational awareness based design drives design itself, also drives training. So when you are planning a training program, you need to focus on the most important parts that users are having problems in situational awareness. If the user is not aware of the situation, then that means you need to focus in that part in the training so that they will improve their conditions. If you can't design, if you can't change the interface. Also, it changes the evaluation of people and the interface because if the interface is not understood, then forget about it. People cannot use it. And doing that, we start with the goals. What is your goal? Goal-directed task analysis done. First, primary information requirements, secondary requirements, and functional requirements are set. We go over on that and make the design. Once we make the design, we go to evaluation. In that, we are also working together with the automation. Our goal is to fix the something, fix the task, fix the target problem, but there is an automation too. So human coordination and understanding of the automation is critical in situational awareness, because when automation starts doing something and you may get lost sometimes. So situational awareness is critical for overseeing the automation. When automation is working, sometimes you need to stop, and in order to be able to know when to stop, you need to understand how automation is working. If you get lost in watching the automation, then you cannot intervene, because you will think it might be doing correctly. So it is human against machine. So human may think that the machine is doing fine, but I am wrong. Then they don't intervene. So because they didn't understand it. Therefore, it is critical for overseeing. Overseeing means controlling and watching together. Overseeing and directing problems as basically understanding what automation is doing and problems with the workload. Şeyi hatırlar mısınız? Robotlara mehter marşına göre oynatan bir yer vardı. Video vardı. Bakalım kimler beni dinliyor.
Yok hocam, duymamıştım önceden.
Fabrikalarımızın bir tanesinde robotlara mehter marşı na göre oynattılar. Onu ben hemen getireyim size. Şimdi bir saniye. Hemen getiriyorum. Evet, şu.
As reliability has become more and more important,
Ses geliyor mu?
Geliyor hocam.
the voice of the maintenance engineer has become stronger. One explanation is the increasing focus on sustainability. Reliable maintenance is sustainability put to practice.
So obviously, your training, because we are not robot operators, we are not robot engineers now, we immediately realize that they are playing mehter. One factor is they are playing music. If the music is not present, it will take more to understand that they are playing mehter. Second, there is a visual cue. There is a stick of the guy. So that also gives the cue to understand what the robot is doing. And the third one is the dynamic behavior. Dynamic behavior of the robot arm is like similar to a mehter soldier. Therefore, we understand what is happening. If, as the music is playing, if the robot becomes like this continuously, at some point, we will believe that it is out of control and we have to stop it because it's not playing mehter anymore. How do we know it? We know it because we are overseeing it, we are directing it, and we are continuously controlling the variables, correlation of the variables, correlation of the music, and the and our training based on the mehter marşı. So we expect some behavior, and that expected behavior is not visible anymore. Then we say it is broken, it is kafayı yedi, etc. And then we stop. So in regular tasks, obviously robots are not for playing mehter marşı, but in regular tasks, similar behavior is expected. Some sound is coming from the robot, some visual performance is coming from the robot, and also some technical performance problems, technical performance characteristics are visible from the control panel, like how much current is consuming, what is the temperature of the endpoint, etc. So if those are beyond your expectations, then you say it's not working normally and you stop, you intervene, and you give control. In order to be able to do that, the continuous information flow must be provided. Otherwise, you won't be able to control. You will just watch that it will fail. There are autonomous robots such as neydi Google'ın aldığı robot firmasının Boston Dynamics. Consider Boston Dynamics robots. They sometimes fail. But when they fail, we don't know what to do. We just watch because we are not in charge. As a consumer of those robots, we are not in charge. But suppose that you are an engineer responsible from that kind of robot and automation, then you will understand based on the interface, you will understand that it's becoming problematic and it is failing, and then you stop, you try to correct the behavior before it goes too bad. That kind of automation is not only physical automation, but also database automation, process automation, web service automation, banking database, and big data, IoT. So those kind of automated process can be controlled and overseen by the operator. Sometimes automation surprises us. Sometimes automation fails, but there is nothing to do. Also, sometimes we are in trouble, but when we are in trouble, automation cannot help because automation is only for the good times. İyi gün dostu. Good times. For the bad times, there is no help when the most is needed. Okay. So the famous Paul Fitts said, what are the issues that computers are good at? What are the issues that people are good at? Today it is kind of changing, but by the time it was 1951, this was the case. Some of them are still valid today, but some others are not valid, such as pattern recognition. He said pattern recognition is also doable by the people, not the computer. But today it is incorrect. So I put it here for as an anecdote. When we talk about autonomy, there are multiple definitions and multiple levels, but two main differences, two main categories exist. One of them is non-autonomous automatic systems. The second one is autonomous automatic systems. Non-autonomous automatic systems does exactly what it is told to do, and they don't make decisions. Autonomous automatic systems has its own plans, changes the plans, makes decisions, and so when you are interacting with the autonomous systems, the problem is more difficult, like interacting with the autonomous robots, interacting with the autonomous drones, and if this or autonomous process in the virtual world, when you have an autonomous process, interacting and controlling becomes, and being aware of what is going to happen becomes more difficult. Such as, it's interesting to note that in order to get the control, operators turn off automation. So automatic mode and manual mode, operators switch to manual mode to get better control. So it is kind of irony. All automatic systems, therefore, should be transparent. If you show that what you are doing, it is more beneficial for the user. All the time, your processes should say, I am doing this, I am doing that, I am doing this, I am doing that, or this is being done, this is being done, this is being done. So giving proper feedback about what is happening increases the control feeling and control possibility in these kind of systems. The Airbus book says, the correct level of automation often is the one that pilot feels the most comfortable with, depending on the knowledge and experience of aircraft and the system's skills and confidence. That is what they say. This is the famous accident then that we discussed at the beginning. Again, this is a typical situational awareness and user interface accident. After the accident, they changed the design of the interface. So operators need to be in full control to have high and continuous situation level. Dinlemiyorsunuz herhalde. Ya sesim gelmiyor ya dinlemiyorum.
Şimdi geliyor hocam. Az önce gelmiyordu.
Tamam. So diğer arkadaşlara geliyor mu? Herkes burada mı?
Şimdi geliyor hocam. Biraz önce kopmuştunuz galiba.
Evet hocam.
Tamam. So these are the good examples of showing complex dynamic information. And what else? Research says dynamic information, as much as possible information, is required. And operators often lack overview. Overview is interesting, like understanding general condition as an overall status. Some operators are forced to concentrate on the tool, not on the task. When they concentrate on the tool, usually problems arises. It is not the tool; it is the task that you should be interested. Then the operators make errors. Sometimes there is a tunnel view syndrome. You focus to one problem. Once you are focused to one problem, that is the end of the tunnel. Other problems are not visible. Other problems may be bigger, but since you are focused on one problem, other problems are not seen. That is what we call cognitive tunneling. Much information is not a problem if visualized properly and filtered properly. Bad design and visualization is generally a problem for situational awareness. It should support correct mental model formation, automation of actions, and pattern recognition by eyes. So that kind of visualization is said to be a good visualization for any kind of data. Common problems are some people put everything in one screen. Then it can cause problems. If you put everything on one screen, those must be the correct ones with the true meanings, and it has to be It has to be perceived efficiently, then it will be good. If it is painted very nicely, etc., but if it's not perceived, it's not good. So colorful, nice-looking interface may not be good, may not be beautiful. Cool is not only all the time functional, so this is important. Oops. Cool is not always good. Useful information must be based on good human factors, and it has to optimize decision-making process. So that means it should support situation awareness process. There are principles. Organize the interface information around goals, because the goal is controlling the train, controlling the Airbus, controlling the car, controlling the technical equipment. So organize the information around the goals, what to do. Second, support comprehension, level 2 situation awareness. Support level 3 projections for future, like drawing graphics. Support 4, principle 4, support global situational awareness about what is going on generally across the goals. Principle 5, support trade-off between goals-driven and data-driven processing. So focusing on data too much or focusing on the goal too much must be balanced, such as avoid attentional narrowing. Focusing on only one thing like this and losing the big chunk of data on the other place is not good. Then make critical cues for schema activation salient, visible. That means determine key breakpoints and classes of situations. Some doors are opened, some gates are closed. So certain big changes in the interface must happen for big key points, so that those key points are recorded in the head of the user. Interface should support comprehension, details, future information. Like this is one example from the Ansley's book. You show the variables. You show the variables, plus you also show the future. The future says it will increase based on this. So good comprehension of variables. About this is the population data. And our for the command and control, air pilot interface, heads-up display are one key example that we can compare everything to. Fast, easy operations, one-step access, situation understanding at a glance, just by looking, oh, okay, that's working. So that kind of at a glance situation understanding, tailored information around the goals and then decisions, easy monitoring across multiple task demands, integrated collaboration tools if there is a collaboration, and generally warfighter example can be taken seriously in many other areas. This is another example. Maps, status displays, and multiple parameters with different colors. So if these colors are red, then it means there is a problem. So by focusing on all these concepts through modeling and prototyping and the theory and experience, we go to our final design. But before we go to final design, we make User in the loop simulation testing. In the user in the loop simulation testing, we do the following. We make the simulation of the system, of course, in the prototype. From time to time, we turn off the screen and ask questions. When we turn off screen and ask questions, if they are able to answer questions, certain questions, then we say, okay, the interface is good. If they're not, that means they are not aware of the situation, but they will try to understand if asked, and that is different. For example, is the train engine is overheating now? That question can be asked in two ways. One, by after turning off the display. Two, before turning off the display. If you ask after turning off the display, that means the person should be aware of the temperature. Second, the person is not aware of the temperature, but if you ask the question, he will or she will check, and it's not good. So situational awareness experiments and in testing should be done by turning off the interface and asking questions. Okay, that's critical. So in the evolution, the environment is becoming more complex. We should be able to handle unlimited information in real time, but if processed correctly, if it is not processed correctly, we can't. There is unlimited information, but we can handle it. So it's the old versus new patient records, for example. We can handle the patient records, much more complicated patient records, easily with the good interfaces. If the interface is bad, then we won't be able to handle whether we use good computers or not. If it is not organized and presented to the user in a good way, we can't do it. Maybe this one is much better for some doctors because the interface is not as good in the tablet. Some doctors miss the old-fashioned way because the interface is not good. The situational awareness of the patient is not good. So basically, too little information and bad visualization are the key pitfalls. As a conclusion, for decision making, it's critical. Many theories are taken from the military equipment and examples, and situational awareness can directly be enhanced through improved systems design and through information sharing and integration among devices. And implementation of automation and unmanned systems has been found to be challenging for situational awareness, must be approached carefully to avoid problems. So autonomous systems are interesting, and further research is required. There are measurement tools for measuring situational awareness, but basically what you do is you turn off the screen and information, ask questions. So if the answers are correct, that means the guy is aware of what is happening. Otherwise, it is just sitting. Okay. That's it. Let me stop the recording, and if you can ask questions, I will answer.